Headset's great. Thank you for coming. So today we're going to talk about advanced continuous delivery best practices on AWS. So I'm Leo Zhadnovsky. I'm a principal solutions architect at AWS. And again, thank you all for coming. And so we've got over 20 years of experience as a company operating both Amazon.com and AWS. And so we'll talk about kind of the lessons learned and how that translated into our continuous deployment best practices, how and why you should deploy those best practices on your or by yourself, and where and how you can integrate security testing into your CI/CD pipelines. So as you build your pipelines to build your code, test your code, deploy your code, monitor your code, how do you integrate security testing into that? Because security is obviously really important. And ultimately, make sure you leave feedback at the end. So we'd love to keep improving this talk to make sure that our attendees of our summits get a lot of value for their time. So go through the app for the summit and make sure at the end that you fill out the survey if you have time. So before we begin, let me kind of tell you about continuous delivery at AWS and what that means if you're using our services. So these are the different stages of the software development lifecycle, right? You've got your source code, so that's when you've got you're writing your code, you're doing your peer review. And then you got your build stage, so if you have to build your code, if it's a language where it has to be built. And then you've got your pre-test, so that's when you're testing your code, and then you deploy your code to staging environments, to integration testing environments, ultimately to production environments. And then after your code's up and running, then you've got the post-test stage. That's when you make sure your app is running according to your specifications. So then we've got continuous integration, continuous delivery, and continuous deployment. So continuous integration, right? It's all that is when you have your source code and you commit it to the mainline branch of your repository, and basically every time there's a commit to the mainline branch, a series of tests are run. So they're unit tests, syntax tests, style checkers, that kind of thing. And your code is then built. And so either the build is successful and you have an artifact that you can then deploy. That artifact could be a serverless function in a zip file, could be a container, like a Docker container, could be an Amazon machine image, could be a zip file, could be an MSI, whatever it is that you're actually using to deploy. Or your build fails and your developers have very quick feedback to be able to fix whatever the cause of the failure was. Then you've got continuous delivery. So continuous delivery is what most of the customers that I talk to when they say they want to do DevOps, what they actually mean is they want to do continuous delivery. So continuous delivery is when you not only build your artifact automatically, but you run your tests, you do your deploys, and so you deploy a staging and you deploy to production, and it's all with full automation. However, you usually have a manual, for it to be continuous delivery, you have a manual approval process in between, right before you get to production. So everything's automated, but before the code gets pushed to production, somebody has to go in and make sure, okay, this commit makes sense. I'm going to go ahead and say yes and deploy this to production. So that's what most of my customers are going for. They want automation, but they still want the safety measure of having a manual approval process before you go to production. And then there's continuous deployment. So as you go down this path of automation, you're going to build up operational excellence in these processes. So you'll get more confident in how you do automation, in how you're doing your automated tests, in how you're doing your deploys. And so then you might decide, okay, this microservice that's part of my app, this one I feel safe just doing full automation on. We don't need a manual approval anymore. So that's continuous deployment. And some of my customers, they never do this. Some of my customers, they'll put a few low-risk microservices with full automated deployments. And then some customers, they do this for everything, right? But most of my customers, what they're really looking for is continuous delivery. So let's talk about continuous delivery best practices. So one thing that we're assuming, since again this is a more advanced talk, is that you already have all this stuff in place. And we're going to talk about more advanced practices. If you want to do a more introductory course or a session on our code services and our developer suite, there's a session I believe tomorrow. It's called the 2 Pizza Talk, and it talks more about like just the basics of code commit, code deploy, code build, code star, and the rest of our developer tool suite. So, what do we mean when we say continuous deployment continuous delivery best practices? So your source code, it's versioned. So it's in something like Git, and my customers, they typically use GitHub or Code Commit or GitLab or Bitbucket. Doesn't really matter. What's important is you're using a version control system for your code. You've got an automated build. So again, when you commit to your version control system, that triggers an automatic build, and that either passes or fails. And then that artifact that's generated from your automated build, it's automated in its deployment. So it gets deployed to a bunch of environments until it gets to production. Ideally, right, you're deploying to more than one instance, so you don't have any single points of failure in your architecture. So when you deploy to something, if that deployment goes bad, you still have another instance running the known working version of your code that you can fall back to. You're doing basic unit tests on your code. You're doing integration tests to make sure that as you deploy your services, they work well with the rest of your services that comprise your application. And you're doing continuous delivery. And lastly, you have an operations dashboard. So you have some kind of dashboard that shows you what is the status of my code, what commit is currently deployed to production, are my builds passing or failing, what are the metrics that I care about for my code. So for example, for a retail website like Amazon.com, orders per second is an important metric. Depending on what your business is, your metrics that are important are going to vary. And so we can kind of tie this to these stages that we'll talk about in a second. And so let's talk about the tools that we'll be using in this talk. So for monitoring, we've got Amazon CloudWatch. CloudWatch gives you monitoring. It gives you metrics, both built-in metrics that services give you and custom metrics. So if you have a metric like number of Tomcat processes running on my instance, you can inject that metric into CloudWatch. CloudWatch also does logs, so you can send application logs or any other kind of logs to CloudWatch. And there's the CloudWatch events, so you can trigger, for example, Lambda functions off of an event. So you find that your instance reboots. That means you have to redeploy your code to a new instance. So you can hook that up with CloudWatch events, for example. For software development, we'll be talking about SNS, our Simple Notification Service, and Lambda, which is our serverless compute service. For continuous delivery, we'll be talking about using AWS Code Deploy. And for continuous deployment, we'll be talking about using AWS CodePipeline. And for security, we'll be talking about Amazon Inspector. We'll also be talking about using some non-AWS tools for that. And lastly, for doing both builds and tests, you can use AWS Code Build for that. So let's see how these services map to the software release steps. So for monitoring, again, we've got CloudWatch and we've got X-Ray. So X-Ray is our distributed tracing service. So for example, if you want to use X-Ray with your Lambda functions, what you can do is just, as you configure your Lambda function, you can click enable on X-Ray, and then it'll automatically start monitoring it, and you can go and do a distributed trace of your Lambda function. But you can also plug in X-Ray into other services and languages as well. Then we've got Code Commit. So Code Commit is our managed Git service. Code Build is a service that you can use for both builds and tests. And also, most of my customers, when they do testing, when they do things like integration testing, UI testing, they're also using third-party tools for that a lot as well. And for deployment, we've got a lot of different deployment services. So we've got Elastic Beanstalk, we've got OpsWorks, but today we'll be talking about Code Deploy. And to kind of bring all these things together, we've got CodePipeline. So what CodePipeline does is it orchestrates the movement of your code to eventually going into production through all of these stages, however you have them configured. So CodePipeline will monitor your code repo, As soon as there's a change, it's going to do a build and code build. It'll run some tests. It'll do deploys to different environments. And ultimately, you'll have an artifact that's in production. And again, how you configure that, which of these services you use, which third-party service you use, that's all configurable in CodePipeline. So then we've got CodeStar. CodeStar is a really good service for getting started with these other services. So let's say you just want to kind of kick the tires, try these services out. You can go to CodeStar. It has a bunch of templates, so you can, for example, do a template that lets you, pick a project that's built in Node.js, and it's going to use Lambda functions. And so what it'll do is it'll spin up a code commit repo for you. It'll set up a code pipeline. It'll set up a build. It'll set up deploys. So it'll take some combination of these services, and within like 5 minutes, get you up and running on them, so you can see how they work and you can see how deployment works in it. And CodeStar also has a built-in wiki tile. It has Jira integration as well. And it manages members of your team. So it's a great way to just kind of get started and play around with these services. Outside of our developer tools, which are the tools on the left side of the slide here, we've got infrastructure as code tools. So CloudFormation, right? So CloudFormation is basically you write a JSON or YAML template, and that defines your AWS infrastructure. So, let's say you've got an app. The app's using load balancers and EC2 instances and auto-scaling groups and RDS instances and CloudFront distribution. Instead of manually setting all those things up, you write a CloudFormation template that describes the infrastructure as code, and then you can deploy off that template. We've also got OpsWorks. So OpsWorks is basically managed Chef or Puppet. For logging and monitoring, there's CloudTrail, which is an audit log of all your API actions. There's CloudWatch, which we discussed, X-Ray, which we discussed, and AWS Config, which I'll show you the use case of that here. But AWS Config is basically like a CMDB-like service, so it records the configuration of resources in your AWS account, so you can go back in time and say, what did this instance, what security groups was it connected to, what tags did it have at this moment in time. So for any supported resources, it stores all that configuration information in there. So what you can do is translate this abstract release process into CodePipeline. So even if you're not using CodePipeline, like if you're using an open source tool like Jenkins with the pipelines plugin or using something else, you can translate this into whatever you're using today. But I'm going to use CodePipeline since that's a service I use most of the time. And so these stages map into different stages in CodePipeline. So this whole thing here, this is the pipeline in CodePipeline. And then we've got distinct stages. So there's a source stage, a build stage, an integration stage, and a production stage. And again, how you define these, totally up to you. And then within each stage, you can have multiple actions. So you can have sequential actions like what's here, and you can also have parallel actions as well. And these actions are what actually trigger events that happen in your CodePipeline. And then we've got transitions. So when one stage is done, when all the actions are done, if they're all successful, it'll transition to the next stage. And you can disable these transitions as well. So if you've got if you got a fully automated deploy without manual approvals and your testing's not quite working, and you don't want your code to get to production, you can disable the transition to production, and then you can keep debugging it in your test environments until everything's stable. Then you can re-enable the transition to production. But until you do that, if the transition is disabled, it won't go on to the next stage. So let's see how this works. We create a revision. That's a change, and they'll run through all of these stages and actions. And assuming it works, it gets to the end, and the pipeline run is considered successful. So let's look at the starting point here. So our pipeline is configured to use code deploy to deploy to 3 hosts. So using the code deploy defaults, we'll deploy to production 1 host at a time. In this example, we have 3 hosts in each AZ. So we're using code deploy. We've got 3 hosts, and we're deploying to them. Why are we doing 1 host at a time? Well, since it's production, I don't want a bad deployment to automatically deploy to all 3 of my hosts and then cause downtime. So if I do deploy to 1 host, check that it's healthy, validate, go on to the next host, go on to the next host, then I can be sure I have healthy hosts that are serving traffic. If I don't do that, I could experience an outage. We also have each host in its own availability zone. Why do we do that? Well, if there's some kind of service issue, there's a flood, let's say in Virginia, and one of the availability zones goes down, well, you've still got hosts in the other 2 availability zones. And having 3 hosts in one availability zone costs the same amount of money as having 3 hosts in 3 availability zones. So just use 3 availability zones. And we're going to keep modifying the slide through this presentation to kind of go through all these stages. So if you would like to dive deeper into, we're going to be talking about doing this kind of with EC2 instances, but if you want to dive deeper into doing this with containers and serverless, there's a talk tomorrow called CI/CD for containers, a way forward for your DevOps pipeline, and it talks about how to use some of these code services for containers and also for serverless. And if you want to check YouTube for Dev 309-R, is a really good talk from reInvent by one of our principal engineers. And it talks, again, about deploying to serverless and containerized applications. And it should be on YouTube, so you can see the whole video. You can get the slides on SlideShare. So let's talk about automation here. So an automated pipeline, what does that actually mean? That means that the actual pipeline itself is defined as code. So in terms of AWS CodePipeline, that means that you've got a CloudFormation template that defines your actual pipeline. That pipeline should be checked into a version control repo. So you've got your CloudFormation template, you're storing it in a code repo, such as code commit. So you're treating your actual infrastructure as a piece of code. You can use this pipeline with both AWS services, so code deploy, code build, all the stuff I talked about, but also third-party services. So if you've got a third-party loading service or a load testing service, or you need to trigger a security test, you want to be able to trigger that from your pipeline. You want to be able to get really fast feedback on if the pipeline passed or failed. So the developer that's pushing code, they should be able to see and get alerts on, did my deploy complete successfully or not? And if not, why? So other opportunities for automation. All of your continuous integration processes, so your builds, your integration tests, your UI tests, your security tests, this should all be automated. So, for example, there's talk a few years at reInvent from one of our service teams about how they integrate or they automate UI testing, and it was using some open source UI testing suite that I forgot the name of. For security testing, we'll talk about that in a second, how you can automate that. For build, you can use something like CodeBuild. For integration tests, CodePipeline both supports, you can do something with CodeBuild, or you can do something with Jenkins, for example. You also want to automate your health checks, right? So you want to be able to see, is my application healthy or not after each stage of the deploy automatically. Your application tests, so synthetic user tests, application performance monitoring. You can get some of this from X-Ray, but most of my customers also use a partner solution like New Relic or Datadog or AppDynamics or something of that sort to do APM monitoring. And you want to have notifications and alerts for when both things go badly and for when things go well. So you want to have your CloudWatch alarms configured on your deployments, and you want to also probably use some kind of third-party tools. So again, Splunk is a really common one, Datadog is a really common one. And you can wire these alerts and notifications up with SNS. So SNS is our simple notification service. So that could give you push alerts on your phone, it could give you an SMS text message, it could give you an email. So you can configure different consumers of that notification service. A lot of my customers have their alerts hooked up to something like Slack or other kinds of chat services, and we'll talk about how to do that. And also pager duty. So something's down, you got to wake some people up at night. Something like pager duty is a great tool for that. So let's talk about how to do our builds and tests. So each commit to your source code repository is going to trigger a new pipeline run, right? So the pipeline is looking at, in this example, the code commit repo, and it's waiting for a new build. So you trigger your pipeline on a source change. That'll automatically trigger this whole pipeline to be run. So the first stage that runs after the source is the build and unit tests. So in this example, we're doing that in CodeBuild. So CodeBuild just spins up a temporary Docker container and runs whatever commands you tell it to run. So you can integrate it with your existing test suite. You can kind of do whatever you want there. And then you deploy to an integration environment. So this is using code deploy. You probably have a set of instances. Those instances are in an integration environment that's very similar to production, but it's not production. And then you are running integration tests. So you do things like, I want to see how this web app that I'm building looks on Chrome. And I want to see how it looks on different versions of Chrome. So for example, you can use Selenium for that, which is an open source tool. And you can trigger that Selenium to be run in code build. And then you might have a custom integration test. And so that, let's say that's a Lambda function, right? So Lambda function, you can put any kind of code you want in it. So we're going to write a custom Lambda function, and we're going to trigger it with CodePipeline. So one thing that's important, again, we want to be notified when a build fails, right? So we're deploying a change. It turns out that this change is broken in one of our versions of Chrome. So what do we do? How do we get alerted on that? So CodePipeline is integrated with CloudWatch events. So every time, if you set up CloudWatch events with your pipeline, you can get almost instant notification that your pipeline has failed. Once that's failed, you can take your CloudWatch event and you can trigger a Lambda function off of it. So you can write a Lambda function, or I'm sure you can find one if you search it on gist on GitHub, that will alert you on Slack. So your engineers, they're sitting on the Slack channel and they get a notification, hey, this build failed. So they know immediately that it failed. They then trigger another change, and now they've broken something else, so it's even earlier in the build. And so all of these will trigger the same CloudWatch event, so they can trigger the same Lambda function to notify you that the build has failed. Now you can also trigger CloudWatch events if the build has succeeded. So if you want notifications for when it succeeded as well, you can do that too. Let's talk about integrating security testing in your pipelines. So you want to automate as much of your security testing as possible. When you're deploying to production and then you check after the fact and you have someone manually check it, manually scan your code, your code's already in production, so there's a risk of, even if someone finds something, it'll be after the fact. The bad guys can find it first, right? So you don't want that. You want to, and also if you're doing your security testing before you go to production and it's manual, you might be slowing down your code actually getting to production. So that's bad, right? So what you want to do is you want to integrate your security testing. A, you want to automate it. B, you want to integrate it into your pipelines. So you want to have an action in your pipeline somewhere that triggers a security test. So if your pipeline is producing Amazon machine images or Docker containers, what you can do in your pipeline is you can use tools like Amazon Inspector or open source tools for containers like Claire, or a commercial tool like Twistlock. And so what these tools do is you can spin up a version of the container, for example, you just built. You can scan it, and you can wait for it to finish scanning, and you can see, okay, this container image is fine, or it's not fine, and you continue or stop your pipeline based on that result. Same thing with the AMIs. You spin up an EC2 instance, you run an Amazon Inspector scan on it, you wait for the assessment to finish, and if it passes, great. If it fails, you stop it from ever getting to production. Also, if you're using any other kind of tool and it has an API, that means you can build a custom Lambda action to trigger that tool from CodePipeline. You trigger it. You have the Lambda function, wait for the tool to finish executing, you fetch the result, and you issue a pass or fail in your pipeline based on that. So again, if any of these security tests fail and you haven't integrated properly, you can make sure that anything that fails the security test does not make it to production. So let's take a look at how this looks like. So one other thing that's fairly new, aside from GitHub and code commit, you can actually use ECR, which is our Elastic Container Registry, as a source code, as a source stage in CodePipeline. So you can have one pipeline that builds your Docker container, and you can then, when that Docker container is dropped into ECR with a certain tag, that can trigger another pipeline that then deploys that container. So in this example, I've got my app, right? So I've gotten a new, instead of source change, I've got a new Docker container that's been dropped here. This triggers a security test. So I have a Lambda function. That Lambda function triggers Claire, which is, again, this open source container testing framework. And then I'm going to deploy to my integration environment, and do my tests just like I did last time, right? So I'm going to execute my UI test, execute my integration tests, and everything's great. So, and it's the same situation. If this fails, it's just going to trigger my CloudWatch event, trigger my Lambda function, notify me in Slack. So I'll know, oh, I need to change what version of some package that's insecure in my Docker container. So if you're building Amazon machine images, similar sort of story. So I've got my code for my application and code commit. I'm triggering on a source code change. So then I can use code build. And so code build is going to build my AMI. And we've got a blog post on that. I'll show you the URL in a second on how to do that. So you're going to build your AMI. You're going to launch a test instance with a Lambda function. That Lambda function then triggers an inspector run. So you've got a version of that instance running with that AMI that you just built. You wait for it to finish. You kill the test instance, and then assuming everything passes, you go on to the next stage. So if you want to learn how to build AMIs, we have a really good blog post on using Packer, which is an open source tool, and AWS Code Build. Also, a really nice thing is, so if you just need to run for a security test, like any AWS CLI command or any bash command or any kind of shell command, you can actually do that. So in code build, you literally just give it commands to run. And in Lambda, you can now do custom runtime. So I'm sure you can find a runtime that's running bash or ZSH or whatever your shell of choice is, and then just run any kind of arbitrary bash command. So, for example here, I've got a really simple security test, right? It's a compliance test. So I've got my code and code commit. I've got this compliance test, so it's going to run a test in code build, and my code in this case is Python. And what I'm doing is I'm making sure that in the requirements.txt file, because it's a Python package, it's only using Python modules that I approve of. So if that passes, I'll do a deploy. So what that looks like is something as simple as this. So basically, I'm comparing a whitelist.txt file, which is a whitelist of approved Python modules, with a requirements.txt file, which is what the requirements of my Python script are. And if they don't match, it'll fail out. That'll cause the code build project to fail, which will cause this not to get deployed to the next stage. So you can do something as simple as this really easily with both code build. You could also, I'm sure, do it with Lambda as well. So just to summarize some security tools options out there. So for containers, these are the ones that I've had experience with. Claire is an open source version option. Twistlock is a proprietary option. For scanning instances, Amazon Inspector is really good. For doing any kind of custom testing that doesn't fall under this, again, Code Build and Lambda are both great. So let's talk about the next best practice here. So making sure that your deployments are actually healthy, right? So what you're deploying is actually functional code that returns what it's supposed to return. So we're going to build this on top of our foundation of automation. And again, this just verifies that what you're deploying is actually working. So an example of this that happened internally is one of our teams built a new service. They were getting ready to launch it. And so our operations dashboard review is a standard step when we're preparing to release a new service. So in the review, we noticed that the service was unavailable when we tried to deploy a test environment. On a deeper inspection, we found out that after one deployment, we had a database migration that wasn't functioning properly. Like we renamed the database table and spelled the name incorrectly, and that caused the deployment to fail. So the team redeployed, and they didn't think anything of the situation. But during that deployment window, they found that not one host in their fleet was serving traffic. They were completely down, and so they should have had like a health check, an automated health check to check for this. So we're trying to, basically stop this kind of thing from making it to production. So when you're using code deploy, let's say you're using rolling deployments. So here's what a successful deployment looks like. So It's going to go one instance at a time, and it's going to update the version of the code on each of these instances, and you've got a fixed number of instances to version 2.0. So each host is taken out of the load balancer while the host is updated, and then it's placed back into the load balancer after it's updated. So if this all works, this is great. Everything's great, right? But the problem is, what we want to avoid is this kind of scenario upon failure. So rolling deployments by themselves don't verify that the application actually works. And so what that means is if you make a change that breaks things and you don't have proper testing, you could find out that everything's broken because you've now deployed code that's airing out to production. So now you've deployed bad code, and now from this point you have to roll back, and so you've already had some downtime at this point. You want to avoid this situation. So what you want to do is add safety to your rolling deployment. So for each host that we deploy to, we want to start up the application and just verify that it's at the very least like returning a 200, or if so an OK code, or better yet, have like a health check page built into your application, and that health check page checks like the database health, the connected database, that everything works as it should, and then it returns a 200, and you can monitor for that. So we also want to configure our deployment to actually tolerate a small number of failures. So if we're deploying to 20 instances and one of them fails, that's probably okay, right? It's probably just something wrong with that instance. It's not a systemic issue. So we want to make sure that that's okay and that doesn't stop our deployment pipeline. We also want to figure out if a deployment fails, we want to be able to automatically roll back to the previous version or stop this deployment to actually make it, before it can make it to production. So again, these are the steps that we're doing here. So let's take a look at how to do that. So this is the AppSpec file. This is the file that controls your code deploy process. And the AppSpec file has lifecycle events. So application start is a lifecycle event, and application start, the way that works is it's just a shell script here, and it's going to start, let's say, your Apache or Nginx web server. And then we've got a validate service lifecycle event. So the validate service lifecycle event, in this case, it could be something as simple as a shell script that just curls localhost, right? So the application has been deployed, it curls localhost, and if it's a 200, great. If it returns an error code, that stage will fail, and it will cause the deployment to fail. So let's say we've got this basic thing in there. So now we're going to do a deployment. Everything looks good. We got this validation in there. Oh, one of my instances failed. So again, in this case, if we just by default don't change any settings, this is going to fail the whole deployment. But that's probably not what we want, because most of my instances have succeeded, right? So what we want to do is use something called minimum healthy hosts. So in code deploy, you can configure what is considered a minimum healthy host count. So as long as you have, let's say, 70% of your hosts are healthy across 10 hosts, one deployment is okay, or one bad deployment is okay, even 2 bad deployments are okay. So in this case, those would now be considered a successful deploy. But if you had 4 failures, that's over 40%, right? Or it is 40%. So then that's still a failed deploy. So you can set kind of what your safety threshold is there. So if you want to actually do that, the way you do it is in code deploy, you configure your configuration health, and you can choose the deploy config here. And what you can do is the code deploy default ones, the one at a time, all at once, half at a time, that's actually that's like how fast it deploys. But you can do a custom configuration. So you can configure, say, I want 2/3 of my fleet to be healthy at all times. And you can define that threshold. So to do that, you can use the CLI command. And basically what this does is it creates a deployment config, and it says the minimum healthy host has to be 66% of my total fleet. And so you can customize what metrics you use for those. The other thing you want to configure is rollbacks, right? And this is assuming you're not doing a blue-green deploy. So this is a built-in feature in code deploy. And you can say, okay, when a deployment fails, just automatically roll back to the old version. So the way that this works is, again, we've got this. It doesn't actually change anything about the release process. It's just when it gets the code deploy stage, it's going to basically either pass or fail now based on if your deployment actually works or not. So in this case, it passed. We're good to go to the next stage. So let's talk about blue-green deploys. So the way blue-green deploys work, right, is you've got two groups of instances. So you've got your blue group, which is what is running right now, and you've got your green group. So your green group is a new set of instances that's spun up when you do a deployment. The new code is then deployed onto it. And if there's a failure, it's going to say, oh, this deployment's bad, but you're not actually serving traffic out of the green group. So these are a new set of instances that are spun up, and your load balancer is still sending traffic to your old instances. So this is great. The deployment failed, but I haven't lost any capacity, and I haven't nothing. I just have to fix my deployment, but there's no impact to production here. And then if you have a successful deployment, basically what happens is your deployment goes through. Oh, everything's successful. I've updated all my new instances in my green group. This is marked a successful deployment. And now I can shift traffic from my load balancer to my green group. So now I've had zero downtime. When I switch over, I'm at full capacity on my new group of instances. And I can just terminate my old instances after I'm confident that my deployment is successful. And so that's built in natively in CodeDeploy. So when you configure your application CodeDeploy, you could just check blue-green, and that's what it does under the hood to make that work. So let's talk about also deploying to one segment at a time. So if you consider your production to be one big pool, then any bad change affects all customers. That's a really big blast radius. And the change could be a bad deployment, could be somebody typing a command in that's, by accident into the wrong environment. So you want to be able to catch these kind of issues before your actual users of your application do. And you want to be able to roll back really quickly with the least amount of impact. So we've actually learned this, the hard way several times over the course of our history. And so what we do is we segment our deploys. We break production into multiple segments. We deploy to a segment. We test the segment after a deployment, and then we keep doing it until we deploy to everything that we have. So these are some typical segmentations that we do internally. So the biggest segment is a region, right? So for AWS, for example, in the US, we've got a region in Virginia. We've got one in Ohio, Oregon, California. Then within each region, we've got availability zones, right? So we've got at least 2 availability zones in every region. Then within that zone, you can have a subzonal group. And then you can have a single host, which is a canary deploy. So basically, when we deploy, we start from the smallest segment here and go up. And if something fails at any point, we can stop the deploy and roll back. And ideally, we catch it at the canary or subzonal level before it actually gets to a whole AZ or a whole region. So if your deployment process, you've got one big pool, again, any bad deploy will take everything down, so you don't want that. So the first thing to do is a canary deployment. So canary deployment, again, is just one instance. Then you break it down into AZs, and then you do your post-deployment tests. So I'm deploying to my canary instance. This instance is in production, but it's just one standalone instance. So I deploy to it, I do a test, everything's as expected. I'm then gonna deploy to my first AZ. Everything went well here, do another test. I'm gonna deploy to my other AZs now. Everything's successful. And then I can go on to repeat the same steps in the next region. So what CodeDeploy allows you to do is you can segment your deployment groups by tags and by auto-scaling groups. So if you've got an auto-scaling group, you can deploy it so you can have an auto-scaling group, for example, per AZ, or you can have just tags however you want them to. So when you're configuring your deployment in CodeDeploy, you can specify either your auto-scaling group or your EC2 instance tags. So you deploy to the smallest segment, then you have a test, then you deploy to the AZ number 1 and you do a test, then you deploy to the remaining AZs, and then you repeat it for other regions. So test each segment. So deployment should be valid if you've gathered enough data to make sure that the deployment's successful, if you haven't had any alarms fire, if your tests haven't timed out. And so you can extend CodePipeline with custom test actions and Lambda invoke actions and custom actions which are running on EC2 instances. So all of these have a 1 hour timeout. So if you configure a custom test with Lambda, it'll time out after an hour if it hasn't gotten a result. And if you have a manual approval, that'll time out after a week. So you can also use approvals to trigger tests. So for example, this is typically a manual approval, but you can actually automate it. So when I get it to the approval stage, that can be hooked up to an SNS topic. The SNS topic can have a Lambda function as a subscriber of it. That Lambda function can then it can inspect the metrics that it needs. So again, this is my configuration of my manual approval. That's my SNS topic. These are my actual metrics that I care about. And I've configured, so it's looking at, it wants 120 metrics basically, and it wants the maximum time of those metrics to be 2 seconds. So I've got a change I'm pushing, it goes to that stage. This kicks off this Lambda function. The Lambda function is writing results into a DynamoDB table. And I have another Lambda function that's kicked off by that DynamoDB table, and it evaluates whatever metrics I care about. And so it'll say, okay, I'm looking at these CloudWatch metrics about how much latency is triggered by this new deployment. And if it's under the time that I need, it's successful. If it's over the time that I'm looking for, it fails the function and it doesn't get approved. So let's say everything goes well. It triggers the approval process and it goes on to deploy into production. So this function, for example, this is a node. So again, this just writes to a DynamoDB table, and it writes data, right? And my Lambda function here, it's basically looking at that data, and when it hits whatever the metrics are, it'll go in and approve my manual approval. So this code is you can find it on GitHub, by the way. So let's talk about Canary deployments. So Canary deployments, again, it's a regular production host. It participates in serving production traffic, but a Canary deployment also has its own metric system, right? Because if you have one instance that's a Canary instance and you have 10 total instances, you don't want to look at the instances or the metrics of all the instances, because that'll actually throw off the metrics of just the Canary instance. So you want to look at, for example, CloudWatch metrics just for that Canary instance. And you want to determine, based on that, if your Canary deployment is successful or not. So again, just a summary. You want to segment your production to reduce the impact of a bad change. You want to do minimum segmentation. So ideally, at least segment by region and do a Canary deployment before you go to a full region. Even better than that, go by availability zone. And even better than that, do sub-availability zones. So make sure you test each segment before going on. So let's talk also about deploying into multiple regions. So in November of 2018, we came out with a new feature in CodePipeline. It allows you to deploy to multiple regions and also trigger multiple actions from different accounts from a single pipeline. So if you're in multiple regions, you could do that because you want to have lower latency. So you have customers for your product across the world. So you want to deploy your app all over the place to be closer to your customers, or you want greater availability. So if you're worried about a region going down, you can deploy to multiple regions. So if you're doing that, it's basically taking our last pipeline and we're adding on the same steps. Let me go back here for a second. We're adding on the same steps, but for region 1, 2, and 3 at the end. The last thing I'm going to talk about here basically is how do we make sure, so we've got all these best practices for our pipelines. How do we make sure that they're being followed? So you've got a big organization, developers are following a DevOps model, they're doing their own pipelines. So you want to make sure that new pipelines, as they're created, they follow best practices. So for example, you have a test stage before you go to production, or whatever your best practices are. So and you want to do this because you want to minimize the risk of downtime, right? Because downtime can cause reputation loss, it can cause financial loss. And so what you want to do is leverage AWS Config to ensure your pipeline compliance. So let me show you how that works. So you can build a config rule that alerts when your pipelines aren't configured to your best practices. And the other thing you can do is you can just build a pipeline which only pushes to production, which blocks pushes to production when your pipeline isn't compliant. So you can use an approval process for that, and you can have a Lambda function that looks at the pipeline and figures out if the pipeline's compliant or not. So let's take a look first at the approval action-based pipeline safety check. So we've got our pipeline, and it eventually hits this manual approval process. That goes to an SNS topic. That triggers this Lambda function, which is a safety check. So that's going to look at AWS config. It's going to check through config if the pipeline is compliant or not. And if it is, it'll pass the check and it'll approve the change to production. So let me go here. So the way you do this is, so we've got config rules, and config rules has built-in checks for pipelines. So for example, there's a built-in check that checks that the first deployment stage of CodePipeline performs more than one deployment. So you're deploying to more than one host. So that's a built-in check. You can also write your own custom config rules based on whatever your compliance requirements are for your pipeline. So you create this pipeline, and you wire it up through CloudWatch events. So now I'm taking that check, and I'm basically, whenever it gets triggered, it's going to fire off this Lambda function called disable non-compliant pipeline. So the way this works now is I don't have a special stage in my pipeline. I'm a developer. I just build up my pipeline, and AWS config is monitoring my pipeline from the outside. And basically, as soon as it detects that this pipeline is not compliant, it's going to fire off that Lambda function, and it's just going to push, it's going to disable the transition to production. So if I'm a developer, until I fix my pipeline, I can't push to production. And I don't have to worry about like manually adding this approval stage that I had at the last point. This might be easier if you're managing a lot of different pipelines for a lot of developers, because if they're doing all the right things, everything works, and if they're not, their push to production is disabled. So just to summarize here, you want to use both. You can use config rules and CloudWatch events to automatically remediate non-compliant pipelines. You can also add a common action which checks per pipeline compliance. And aside from that, what you want to do is provide your developers a best practice pipeline to start with. So instead of them figuring it out on their own, you can give them a CloudFormation template that defines what your best practice pipeline is. They can spin that pipeline up and then change it accordingly to their needs, to whatever tools they're using. You could also do this in Service Catalog, which is another one of our products. And something that's pretty new is you can use our CDK product. So this is it's still in preview. So CDK is our cloud developer kit. And so you can define basically in code what a compliant best practices pipeline is for you. And so what they then have to do, CDK supports a bunch of different languages, but they can then instantiate an instance of that pipeline based on whatever module you built with your best practices in it, in like a few lines of code, instead of having to spin up a whole CloudFormation template. Again, you can also use our approval actions in CodePipeline to implement this stuff. So I've got 2 minutes left, so I'm going to talk really quickly about a few more things. You can add even more safety to your pipeline with deployment gates. So basically the way that works is, again, this is typically through a Lambda action. Let's say you've got periods of time where you don't want to do any production deploys. So for example, for Amazon.com, when we have Prime Day, there's an emergency hotfix or something, we probably don't want to do any deploys to production that day because it's a high traffic day. And I'm sure when you're building your app, you have days where you want to deploy to production. So you can build in a Lambda function that basically checks against some calendar you have or some data source. Oh, is this deployment going on during a bad period? And if it is, I'm going to fail, and then it'll stop the pipeline from getting to production. So that's another common practice. So just to summarize what we've learned, you want to make your pipeline safer by identifying issues with your pipeline quickly through continuous testing. You want to get notifications if something passes or even if it fails really quick. And you want to be able to safely deploy changes. So you want to manage deployment health. You want to see after deployment if it's successful or not. And you want to segment your production deploy. So you want to deploy into small pieces and make sure all the pieces work. And if you want to improve latency and availability, you can also deploy across multiple regions. And if you want to make sure that security, best practices are followed and compliance best practices are followed, you can implement features to block non-compliant pipelines. So at the end of the day, what we're looking for is all this stuff has succeeded. We're deploying to production. We're testing. Again, we're doing a traffic test, and everything's successful. And so the only code that gets to production is code that's verified from a security, from a load, from an availability perspective, that's verified that it's successful. So your users aren't exposed to failures. So that's what I had for you today. Please remember to complete the session survey. And thank you for your time. And if you have any questions, because it's a silent disco format, what I'm going to do is I'm going to go out there. There's a meet the speaker area, so I'll just hang out there for probably however long it takes to answer all your questions, and just come ask me a question over there. Thank you for your time.